Thank you very much for joining us today to our first Lambda meetup. So we decided to join forces, basically 4 user groups, the Clojure user group, the Elixir user group, the Lambda, the Scala user group, and the Idris user group to host every half year a joint meetup, which is the Lambda meetup. So thank you very much for joining us today. And we are very happy that Zipgate is sponsoring us today. So I would like to call Tristan from Zipgate, not Tristan, okay, to have a few words about Zipgate. So thank you very much. Give a round of applause for Zipgate for sponsoring this meetup.
Hi, I'm Peter from Zipgate. For those of you who don't know us, we've been doing perfectly fine voice over IP software since 2004 and being agile in that since 2010. For those of you who are interested in our agile work, we have a book. It's called 24 Work Hacks. You can sign up for it in the hallway and you'll get a free copy. We've been working on functional programming a little bit. So it's in a transition right now for us, but so far I can say we're really happy with it, and I would like to continue working with functional style programming. We've been using it in Java, JavaScript, and recently we introduced Akka for stream processing. So that's been a very interesting experience as well. And let's have a great time today. I think there will be some people showing you around later this evening. Have a great night, have fun, enjoy functional programming.
Thank you very much.
Yeah, we're so excited that so many people are here around, and I think now we just get started and let's welcome our first speaker. It's Bendisposto, who's talking about functional programming and what is it. So give a warm applause and let's get started.
So, hi, I'm Jens. Just before we start, is there anyone here who does not understand German? Okay, so then we'll just, because otherwise if there's nobody who doesn't understand German, there's no point in having the talk in English. But okay, fine. So I was asked to give a talk about what is this functional programming that everybody's talking about. So I Googled, what is this functional programming everyone is talking about? And I found a page where called TOB, where programming languages are indexed by popularity. So that's this one. And as you can see, Java, C, C++, Python, C, there is no functional programming language. Which one is the JavaScript, yeah. Okay, so I found a ranking of job openings, and there's actually Scala right here. 2 places behind Perl. So that's the moment where I decided to change the title of my talk. So what is functional programming that almost nobody is talking about? And I come back to that at the very end of my talk and how we can change that. Okay, so what is a functional programming language? So there are a couple of things that characterizes functional programming languages. And the first one is functions are first-class citizens, which means basically they can be pushed around, right? They could be parameter to another function, or they could be a return of a function. So JavaScript. Obviously, JavaScript is a functional programming language. So we've got a function inc that takes an argument x and increments it by 1. If you pass in a number, if we pass in something else, I don't know what happens. Something happens, but you get weird results. And the next function is called apply twice. And as you can see, apply twice takes another function as argument f, and the next, and it applies f twice to x. So you pass around the function. You pass it into this so-called higher order function. So if you call apply twice with inc and 4, you get 6. So now functions can also be returned by another function. So I wrote another one that is called apply twice curry, and it just takes an f, just a function, and it returns a function which takes the x and then applies f twice to x. So this time it takes a function and it returns a function, right? And again, we call it with inc, that returns a function, that if we call it with 4, it will apply inc twice to 4 and return 6. So this is kind of the Haskell style. In Haskell, every function takes exactly one argument and returns a function, takes the rest of the arguments. So, but really, higher order function, there's nothing special about it. It's just functions that take or return functions. And there are a couple of functions that are typical in a functional programming language: filter, map, and reduce. So filter takes a sequence of stuff and filters out some of the unwanted bits. For instance, here we've got some nice colors, and because we hate the blue color, we filter it out. So we apply a filter function where the color has to be not equal to blue. So we get a number of colors, and then we apply a map with a function called first letter that takes the name of the color and takes the first letter of it. So we get black, red, black, and so on. So this is taking a function and applying it to a sequence of values, and you get a sequence of new values, where each value is the result of applying the function to a value. And then finally, there's reduce. Reduce can be used for a huge number of purposes. In this case, I use plus to concatenate the values in the sequence. So this is more versatile than the other ones. So in fact, reduce is enough to do all the others. So this time, I mean, in JavaScript, so we can apply inc to every element of 4, 5, 6, get 5, 6, 7. We can filter out all values less than 6. So this will return a list containing only 6. And we can apply a reduce function. So reduce function always takes 2 arguments. One is the result of the computation so far, and the next element from the sequence. And then we can apply this function to them and produce another combined value. So this one in JavaScript, this will return 4, 5, 6. 4 plus 5 plus 6. So you may ask, what's wrong with the good old for loop? I mean, I've used it for 20 years, and well, what's the problem? I mean, for loops are simple, right? First semesters can write for loops. Okay, let's try it out. So I assume you all are programmers. So we have a simple task. We have a list of numbers. And we want to find the even numbers greater than 5. We want to square them and sum them up. I take k values of the sequence and sum these k values. For instance, here we've got a sequence 10, 11, 12, 17, 14, 2, 20, 12 in both cases. And we say k is 4. So it will filter out every value that is greater than 5, which is these values. 2 is less than 5, and even. So 10 is even, 12 is even, 14 and 20. 12, of course, again. But we limit to 4. So we only take the first 4. And in the other case, we limit to 8, but the sequence does not have 8 numbers, so we take them all. Okay? So now here's the solution in Java. And my question is that a correct solution? Of course, I have 0 test cases. So, who thinks that's a correct solution? 1, who thinks there's a bug? A couple of more. No, I mean, I'm not sure. But I think it's correct. So, but what happens if you want to analyze this code? You have to kind of play a computer in your head, right? You have to follow the code, and it goes around and around, and you start flickering with your eyes, and it's really hard to follow, actually, because it mixes up the computation and the looping. Yeah. So here's a functional version, also in Java. So again, we take a list. Ooh, fancy. So we take a list of integers and the k. So what we do is we turn the list into a stream. That's just a technical thing. But then we filter all the even numbers. We filter all numbers greater than 5. We square them up. We limit to k, and we sum. So is that correct? Yeah. You're sure? So, yes, it is correct. Except there's one thing one might ask about limit, if that does what it's supposed to do. So what happens if there are less than k values? Yeah, limit has the correct semantics. But that's the point where one should look up. The other stuff is pretty clear. Yeah. So easy. So higher order functions can help us to abstract away stuff that's boring, like iteration logic. And we only keep the semantics, we only keep those parts that are interesting. We don't have to play a simulator for computer. I mean, we built these things to not do that, right? So you can't read that probably, but mixing logic, iteration logic with domain logic is called, what a closure programmer would say, it's complecting. Okay. So is Java and JavaScript, I mean Java greater equal 8, are these functional programming languages, as suggested by Joy? I think there's something missing. I mean, yeah, one could say every language that passes around functions is a functional programming language, but I think side effects should be considered, or handling of side effects. So pure function is a function that has no side effect. And pure functions are really, really important because they are super easy to test. They are easier to reason about. I mean, not necessarily super easy, but easier than an imperative version. And they have the wonderful property, I mean, they are basically mathematical functions. So you pass in the same arguments, you get the same result. So if you call it now, and you get 5, you can call it next week and it will still return 5. So you can cache the results, and you can you don't have to worry about concurrency at all. So use them. Even if you're doing Java, use pure functions wherever you can. So again, a Java function. And my question is that a pure function? So we take some integer values as input, we loop over each of them and add them to an integer called output, and then we return output. What do you think? Is that a pure function? Yep. How about this one? So I create an array A containing the numbers from 1 to 6. Then I start a magic method, start A. And I call sum of A. The first time I get 21. I wait for 3 seconds, call it again, and I get minus 980. So do you think that's a pure function? No, it's not. Actually, it's not a pure function. Because there is no purity in presence of mutation. There's no way you get a real pure function if something is mutable. I mean, you can write immutable functions in Java, but only if all stuff that is in that function is immutable. So strings and integers and stuff like that. But as soon as you go to data structures, it's basically over. So I think in any functional programming language, immutability must be the default. I mean, Clojure and Scala as well, they have like hooks into Java where you can call Java code. You can create Java objects, and these are mutable. But at least in Clojure, I don't know about Scala. I did Scala 10 years ago. But probably also in Scala, immutable collections are the default. So what about performance? I mean, in Java, it's really bad, right? So there's copy on write array. So as long as you read, there's no big deal. But as soon as you write, you copy all the values. And that basically screws up every algorithm. But you don't have to copy everything. So here we've got a representation of an array, and it's a tree, obviously. So we've got a root node here, some inner nodes, and in the leaves, we have the values, right? And how this tree is created is not a big, should not be an issue here. So we want to change this 8 to 3. So what can we do? What we do is we create a copy of this node, and we link this copy to the 1, to the 5, and we create a new node, a new leaf node 3, and we link everything back to the original version. So now we've got a change that is not constant time, but if you do the branching factor big enough, then it's almost constant time. So in Clojure, if you have a vector and you change something, it's at most 7 copies. So it's pretty close to constant time. Technically, it's log n. And this works because of immutability, right? You can link to the old versions because you know they cannot change, right? So immutability allows us to be performant, and that allows us to have immutability. Quite nice. But there's other state than mutation going on. So non-trivial programs have some state, right? You have something in a database, or you have something you want to remember between function calls. And there are a couple of ways to control state in functional programming languages. Basically 2 approaches. One is the pure approach, like in Haskell, and the other one is non-pure. So there are side effects in Clojure and also in Scala. So I use a super simple random number generator. Please don't use this. It's super stupid. But I want to get the point across that we, what? Oh. Okay. That we want to pass some state between method calls. So we've got this seed here, and we change it inside the method. So the next time we call the method, it has a different seed. So it's a stateful computation. So in a pure language, what we could do is we could make the state a parameter of the function. So we take the seed as an argument to that function call, and we do our computation, which is just taking the seed as the result, and then we compute a next seed and return both the result, the new random value, as well as the next seed. And we can take this one and pass it into the next call and keep the state flowing around. But there's a problem. Previously, the function returned an integer, so that we can use and compose it with other calls. Now we get a tuple of an integer and some state, so we cannot directly use the result. I've got another example. This is an interpreter for a language that is kind of Pascal-like. So we assign 4 to the value of x, and then we compute y, assign y to the value of x plus 2. Initially, we don't have any value stored, so we call the function assignment, and we assign 4 to x. So what happens is we return 4, that's the result of the computation, and we store 4 in a variable. And then we've got the next one. So we get the value 4 out of our state, and we put back y equals to 6. But we could also do something else. We could pass in this environment. So these red things are side effects, bad side effects, right? They change state. But we can do it in a pure fashion. We pass in an empty state, and we return a tuple of the value and a changed environment. And we take that changed environment and pass it into the next call, which returns 6 and a new environment. So what you have to do, you have to write some glue code that takes the state and passes it around through the function calls. But we know we can extract that glue code into a higher order function. If you do that, and you add another function that kind of produces the initial value, you get something that is called a state monad. Basically, it's just about threading the state through function calls. In impure languages, it's way easier. So in Clojure, you have special constructs that just solves the concurrency issues for you. And there's a couple of them. So they handle the concurrency, but basically it feels like a variable thingy, but it's not, right? It's not a variable. It's some construct that manages concurrency. And there are more side effects, like printing, sending email, launching the rockets, stuff like that. In pure functional languages, they are pushed to the outside of your system. So you do everything pure inside your system, and at the border you have a couple of impure, I mean, technically it's not impure, but side effecty functions. That's the I/O monad. And typically you enforce that with a type system. That's quite nice with Haskell, because if you look at the signature, you know if the function has a side effect or not. In Clojure, you have to read the code. In impure languages, side effects are kind of okay, and it's up to the developers to handle them with care. This sounds like a bad idea, but in fact, there's a trade-off, right? So in Haskell, you get this information that there are side effects, but that may hinder or maybe an obstacle in changing the code. So Clojure code is way more flexible than Haskell code. Yay! So I gave this talk before. I tried it, and I never managed to get it under 45 minutes. So I'm spot on. Great. So summary. Functional programming languages, they reduce and they control complexity in code by splitting it up into pure functions that are easy to test, easy to reason about. And we avoid or manage the side effects. And we've seen that functional programming languages have higher expressivity because we have higher order functions, and we can take boring code parts and extract them into kind of templates where we push in some other functions and adapt to different use cases. So coming back to my first point, how do we get functional programming out? I mean, it's great, but it's very difficult to push a functional programming language into practice, to get managers to accept functional programming languages in your code base. It can be a challenge. So I think we should address Java programmers, and we should address JavaScript programmers and take them where they are. And that's why we will have functional Java workshops, trainings in September. I'm not sure about the date yet, but of course it's a free thing, right? It's not, it doesn't cost anything, so it will be free of charge. And if you want to discuss this or other aspects of software development, you could join the Entwickelbar, which is an unconference taking place in May 26th. There's the link and our QR code for that link. And I'm happy to take questions, or should we defer it? I mean, it's exactly 30 minutes, right? So if there are any questions, or no questions? I just did, right? I just did. I mean, a monad is. I'm trying to resist that urge to say that it's just a monoid in a category of endofunctors. So basically, it's a way to compose things and add some extra. So, for instance, there's a maybe monad that deals with computations that may fail. So, and if you have two of these functions, both can fail, and you want to compose them, you can't use the normal composition, right? So you have to have a way to bind them together. And this is the bind function. It's the same thing as in the state case, where you thread the environment through the computation. In that case, you have a slightly different way to compose things. But the great thing is, once you use or you obey the monad laws, you can use, again, very generic code to compose them. So there's this do notation in Haskell, and you could put in any monad you want. As long as you follow the rules, they will do the right thing. Yeah.
Okay, I think we don't have more time for more questions, so thank you very much, Jens, for this awesome introduction. And now we plan to have like a 10 minutes break until we get to our next talks, and the last 5 talks will be all basically 10 to 15 minutes lightning talks presenting different languages. And so now we have 10 minutes break, and yeah, have a couple of drinks and snacks more, and yeah, then we continue. Did I miss anything?